Alright, now we get to our last transformation, which is called enlargement or reduction by factor, let's call it k. So by a certain factor you are enlarging or reducing something, right? Now you've got an enlargement factor of k, so basically what it means is, whereas the other transformations were all rigid, the shape and the size of whatever you rotated or reflected stayed the same. This one's not rigid because what you end up with is not the same size. It's got the same shape, but not the same size as your original. So let's say I took a little triangle. Let's just do that. There's my triangle there, right? Now, if I enlarge that by a factor of 2, right, then I go from the origin, it's by a factor of k, let's just say, through origin, alright, through the origin, which means you go from there, you draw a line through the point, and you go that distance, right, further on. So that's where that point will end up. Through the origin, through that point, and that distance over there. So there it is. Same thing on this side. I go through the point, and I go that distance there. So there's my new point. So I'm going to draw that there. That is my new shape. You see that it looks the same shape, just bigger than the other one. That's an enlargement of a factor of 2. Alright? So I'm going to use this as an example. Let k be equal to 2. Alright? So, my general rule will again be what happens to the original x, y values. Now, very simple. The coordinate that you have started with gets multiplied by the enlargement factor. So that simply becomes k times x and k times y. So for my specific value, any input value x, y goes to 2x and 2y. Get that? 2x and 2y. So my original coordinates will just be double. So let's say that was the point. That's fairly symmetrical. So let's go minus, let's do that on that side, not symmetrical. So 2 and, let's say that was 2 and 4. That would become 4 and 8. See that? That's my new point. And if I wanted to use my example point that I used there, I go my point 3, 5 would become under this enlargement the point 6 and 10. That's under the enlargement of a factor of 2. So that's enlargement factor Z. Now, when k is greater than 1, we call it an enlargement. Obviously, when k is a fraction, then it's not an enlargement, it's a reduction because the values get smaller when you multiply with a fraction. Then there's also the case where you make that a negative, right? And what happens to a negative? When you put a negative in front of it, then it's the same as saying it is being negative, negative. That's a rotation of 180 degrees, and then enlarged or reduced. Okay, so that's my enlargement. Then lastly, there's one thing that they sometimes ask as well. It's called the area enlargement factor. Now I'm just going to write it down here that the area shorthand enlargement factor will be equal to the one you give me there, k squared. Alright? Which means in my case there, my area enlargement would be 2 squared, which is 4. So the area of the new shape is 4 times the area of the original. Alright? That's it.